Alright, so I am making a video here. I'm going to go over some of the problems from the final review, since we probably won't have enough time to go over as many problems as we'd like in class. So I'm going to pick about three-ish problems per page to go over. Alright, so if you want to see other problems gone over, we'll have to set up a time, or if we happen to have some time in class, but we cannot rely on that. Okay, but just let me know if you want to see some problems. All right, we're going to start off with number 8. All right, so number 8 has a couple of different stuff going on. First, I would simplify the denominator. Okay, for the numerator, we can just leave b, so it'll remain 3x to the third. Now, if you remember, we can multiply the coefficients. That's the 2 and the 4. 4 times 2 is 8. So no problems there. And these both have y bases. So when we're multiplying things that have the same base, we can add the exponents. So negative 2 plus negative 2 is going to be negative 4. All right. Next, we would look to see if we can reduce the 3 and the 8. They are not able to be simplified, so we'll just leave it 3 over 8. We don't like having a final answer with a negative exponent. So if you recall, negative exponents allow us to flip. So if it's a negative exponent, it reciprocates, meaning it flips to the other half of the fraction. So in this case, it's in the bottom half, the denominator, it's going to flip up to the numerator. Now, when it makes that move, it will also become positive. So now we're going to have this 3x to the third. Now we're going to have a y to the positive fourth up there. And then on the denominator, we'll just have an 8. And that's as simplified as we can have it. So there's our final result. All right, another one I'm going to go over is number 10. All right, so again, we're going to start with the denominator. So there's just a couple different things we could do. Let me just recopy the numerator. So we could distribute this power throughout first, or we could combine the like bases first inside. Either one would be a fine first step. I am going to combine the like bases inside the parentheses. So these are being multiplied, symbol right there. So we add the powers, okay? So that will be, staying in parentheses, negative 4 plus negative 3 is negative 7. So that's x to the negative 7th. And the y will still have a power of 4. And that power of 3 will still be on the outside of everything. Okay, now we can distribute this power of 3 through multiplication, okay, to everything inside there. There's no coefficient that we have to apply the power of 3 to, which is nice. We'll just apply it to the powers there. So now the top still is staying the same for now. And now we're going to have x to the negative 21 and y to the positive 12. All right. So now there's a couple different ways we could look at these. One way is subtracting. So when we have same bases on the top and the bottom, we can subtract their powers. Notice that I put a 1 there because there was no number. There's an invisible 1. If we had 0 there, either the x wouldn't be there because anything to the power is 1, or we could just cancel it out because a power of 0 makes it equal to 1, and 1 times other things does not affect the other things. So what we're going to subtract. So 1 minus the denominator, so 1 minus negative 21. If you remember, subtracting a negative is like adding. So it's 1 plus 21, which is going to be a power of 22. And that power will stay on the top. So 22. And then we can subtract as well here 2 minus 12. Well, that's going to be a negative 10, right? We're taking away more than what we have there. So 2 minus 12 is negative 10. We could write a y to the negative 10 on the top and then move it down, but why make the extra step if we know it's going to be, since it's a negative power, it's going to go in the bottom as is. Now, just be careful though, since it's a negative power, it would be a positive power in the bottom. Okay, so that'd be a positive 10 power in the denominator, like so. All right, on to page 2 here is graphing an exponential function. Okay, we're going to check out number 14. So number 14, the first spot that we would like to start at is the the asymptote. And that's what is what's going on that's being added or subtracted on the outside. Okay, in this case, it's a minus 2. So that is the asymptote. It's an imaginary line that goes through the y value of negative 2. And if you recall, it is a line that we cannot cross. We can get closer and closer and closer to it, but we're never allowed to cross it. One of the easiest ways to make to make points is make a table. Okay, make an XY table here. Okay, X, and we can call it f of X, or I'm just going to call it Y here, and we can pick a few values. Calculators can be handy here. Okay, and we are going to, let's go skinnier again. We'll go with 0 in the middle here, negative 1, negative 2, positive 1, and positive 2. All right. So recall that when we plug in these values, they're going in for the x, which is in the exponent. So you'll be substituting these in for the exponent. So when we plug in negative 2 in for the power, 1/2 to the negative second power, it flips it, so it's a 2 over 1, and 2 to the second power would then be 4 times negative 5 is negative 20, minus 2 is negative 22. Okay, if you're using a calculator, you should still get that value. So negative 2, negative 22 is just off the grid. So we could imagine, so these are going by ones, negative 21, negative 22. We can, since it's not too crazy far off the grid, we'll plot that. All right, negative 1, same kind of idea. We're plugging it in for the exponent. That's going to flip it since it's a negative, so this is going to be just a 2 over 1, or 2. Times negative 5 is negative 10. Minus 2 is negative 12. All right, so negative 1, negative 12 will bring us right there for a point. Plug in 0. 0 is kind of nice. It makes this into 1, so 1/2 to the 0 power is 1. Times negative 5 is negative 5. Minus 2 is negative 7. And if you recall, there's a shortcut when there's 0. You just take the front number, excuse me, the front number, and either add or subtract depending on what the symbol is. So in this case, it's negative 5 minus 2. And you just ignore the base number. Okay, now raising it to the power of 1. So this stays a half, times negative 5 is negative 2.5, minus 2 is negative 4.5. Right, so negative 4.5 is about there. And one final value, plug in 2. So that's going to be 1/2 to the second power, so that's 1/4. 1/4 times negative 5 would be negative 1.25. Minus 2 is negative 3.25. And so negative 3.25, a little bit below there. All right, so we can get a nice visual here of what this graph will look like. Let's see how well I can do getting through the points. Now when you get to here, you have to understand how the function works. Either make a bigger table if you don't know what's going to happen from here on out, or remember that this is going to get closer and closer and closer to the asymptote. So your line should gradually get closer, but try not to cross um, that dotted line that you drew. Arrows to show that it goes on forever. All right, something that it does not ask you to do, which would be good practice, is identify the different things. So first off, the asymptote is this line. So I'll write all the information over here. So the asymptote, kind of a funny word. That is y equals -2. Okay, the y-intercept is where it crosses the y-axis, and that is -7. Specifically, as a point, it's 0, -7. Next is the domain. Domain is all real numbers. You can use this symbol for all real numbers, a script R, and then the range. So we want values that are less than -2. So y values less than -2. Okay, not less than or equal to, because we never actually touch this y value. Okay. All right, next we're going to look at number 16. So looking at this one, let's use a different color here. We want to locate some points that we see. So I see the point 0, 3. Okay, that's a good one to recognize. If I go over 1, we appear to be at 6. So that's the point 1, 6. Over at 2, we seem to be up at 12. So 2, 12. 3 doesn't quite get there, -1, maybe 1.5, but really we have enough information that we need right here. Okay, because as we go over from 3 to 6 to 12, we can see a pattern. Maybe you've already noticed it, but it's timesing by 2. So we're multiplying by 2 each time. So we have enough information to write our equation in this form. Y equals A times B to the x power. Okay, so it's y equals, A is our y-intercept, so that's 3. And then B is our scalar factor. So what are we multiplying by as we go to bigger values? Okay, so we're multiplying by a whole number of 2. In this case, it was pretty easy to do mentally. If you're not quite sure what we're multiplying by, you can always take a later number, like 12, and divide it by the number right in front of it, 6. 12 divided by 6 is equal to 2. And it didn't have to be 12 divided by 6. You could have also done 6 divided by 3, also equal to 2. So as long as you take a value that's further right and divide it by a value that's further left, that's going to be your scalar factor.